Hello, welcome to another session of Math. Let's look at this question. So, integral square root of x divided by x minus 1 dx. So, integral square root of x divided by x minus 1 dx. What approach do you think we are going to use, guys? Any idea? Well, trick sub or use sub. Any idea? Well, okay, I heard somebody saying he can solve this one using trick sub. Others were also saying use substitution. Yeah, good. Well, I like your guesses and I like your ideas. Even if trick sub won't work, somebody is saying it will work. Maybe no matter whether it's going to work or not, he's just going to give it a try. There are certain questions um coming out with the approach won't be all that easy unless you try to do you know, some petty workings to find out which approach will easily work out for you. Okay, so here, well, I heard somebody saying tricks up. Okay, so I will leave that one to you guys, that whatever approach that we use to solve this problem, I will leave that one to you, but you make sure you let me know your solution at the end of the day. I mean, apart from the approach that I'm going to use in solving this question, you try any other approach that you think you can use to solve this problem. Okay, and when you are done, please make sure you let me have a copy of your solutions so that I can also go through and see. But well, I will aside any solution, any approach that we'll be using, I will encourage all of you to try and use trig substitution to solve this problem. I just want to know how critically you guys think. Trig sub may work, use substitution may also work. Okay, so you try that one. You try that one. That one everybody should try using the trig substitution. Okay, everybody should try using the trig substitution. But apart from that trig substitution, that I want you guys to use any other approach that apart from trig sub and what I'm going to demonstrate or what I'm going to use in this video, you are to use any other different approach, either integration apart, partial fractions, or any other approach that you think you can use to solve this problem. You use the approach to try your hands on, and at the end of the day, let me know what you get at the end of the day. Okay, well, guys, in this video I'm going to show you how use substitution can be used to solve this problem. Like I said, trig sub may work, but to do that you cannot easily just say this is equal to this. You have to do some one or two things before trig substitution can work out for you. I said may work. So by here I'm going to use the use substitution approach. Okay, so having known what approach that we are going to use, why don't we get started? Okay, so let's start. But before we start, let's write our solution first as usual. Okay, now we cannot just write the solution and just say u is equal to this or start applying the substitution approach. To make it everything, to make our work or presentation look nice, let's first write the question that was given. So what is the question? This is the what question. Don't bring this one. This is the question. This is what we are going to this one is just telling us what we are to do. Okay, So this is what we are going to write. So let's repeat this. Square root of x divided by x minus 1 dx. Like I said here we are going to use the u substitution method to solve this one. There are a lot of integrals that u substitution can solve, but mind you, bear in mind that though we are using u substitution approved by, that does not mean everything is going to be in what u substitution. Maybe first step u substitution, next step u substitution till the very end. No, there might be another approach that we will come across which is helping us to apply our u substitution. Just that the u substitution is going to be more than the other method. So sometimes I just um, 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 choose the approach, in terms of the number of times that particular approach what appears in my workings. So if I use substitution and I realize that at the end of the day, partial fractions dominate u substitution, I'll just name it u substitution. Okay. So like I said, we are using u substitution. So here we are going to do substitution. We are going to do substitution. Now, the question is, what are we going to substitute for? Are we going to substitute this one for maybe, let's say, y? Or are we going to let this one be equal to another variable? Which of them are you going to use? And make sure the substitution that you do make the work easier rather than what complicating it, rather than making it what difficult. Okay, so square root of x divided by x minus 1 dx. If we are to do substitution from here, well, I will let u be equal to square root of x. I will let u be equal to square root of x, and from there I think if I let u be equal to square root of x, then I differentiate. From the differentiation, I might get something that will replace this. And if I let u be equal to this directly, because of the square root sign here, I think we may encounter one or two difficult. I'm not saying if you let u be equal to this one, you are wrong. No, you can let u be equal to this one and then differentiate, provided you'll be able to deal with any difficulty that you come across. With me, I always want everything to be simple for you guys. I don't want to include any complex calculations whereby you find it difficult understanding and fumbling and all those stuff. All that I want for you guys to make things easy for you. Now, if you are able to understand, get the understanding from the easier way. From the understanding, you can also try to solve more harder way by using other different approaches which involve what complex calculations, because you know that I can use the basics to deal with whatever problem that I encounter or that problem that I come across. Okay, so here I'm going to let u be equal to square root of what x. I'm going to let u be equal to square root of what x. Okay, so u is equal to square root of x. Now before we can differentiate, let's square both sides so that differentiation will be easier. Like I said, please remember, I just want everything to be simple. I don't want to include any complex calculation. I can differentiate this directly from here and then move on later on, do change of subject or do blah blah blah, but it will be very difficult for you. But when you understand it from this way, you'll be able to know, from the understanding that you get, you'll be able to tackle some workings that involve complex calculation, or you yourself might even try it from the easier way and turn it to steps that involve complex calculations. Like as I'm doing here, u is equal to square root of x. Sorry, if the understanding is very clear, or if the knowledge that have about use substitution is very profound, I will not bother, squaring both sides before I differentiate. I can choose directly to differentiate from here. Du will be equal to 1 over 2 and 1 over 2 times square root of x dx. And I'm good to go. At the end of the day, I can, make change of subject to find out what is going to replace what x will be equal to. Okay? But because I want everything to be simple and make it easier for us to understand, I always opt for the what? The easier way. Okay, so let's continue. So like I said, let's square both sides. Let's square both sides. And when you square both sides, you're going to get u squared is equal to x. U squared is equal to x. Now let's differentiate. Now you can see that this one is easy than the first one, because this one looks familiar to us. We know how to differentiate things like this as compared to the other one. Okay, so now let's differentiate. When you differentiate this one, you're going to get 2u, and when you differentiate this one, you're going to get what? Dx. So dx will be equal to 2u du. 2u du. Okay, now remember the other time I said when you make substitution, it means you're moving from one word to another. The question was given in x word, and now we are moving from s word to u word in order to help us solve our problem. So in going to what? X u word, everything has to be in what? U word. Everything has to be about u, and nothing of what? X. So whatever x that will be left after substitution or after differentiation, we need to find something that will replace it. Okay, so from the question, square root of x divided by x minus 1, we know that square root of x is going to be replaced by what? U, and x is going to be replaced by what? U squared. U squared. U squared. Provided if I haven't square both sides and then I have maybe differentiate directly from u is equal to 1 square root of x, could have been different. I have to work further, um, finding what is going to what replace x. By squaring both sides makes it easier to know what is going to replace x at the end of the day. So x will be equal to what? U squared. And what is going to replace the x? What is going to replace this one? That is what? This. Okay, so let's put them into the integral. U over u squared minus 1 multiplied by 2u. Remember, 2u du is replacing what? Dx, and square root of x is being replaced by what? U, and this x is being replaced by what? That is u squared. So that is the u squared what? Here. Okay, now u over u squared minus 1 multiplied by 2u. U squared minus 1 multiplied by 2u. Okay, now when you multiply this, you are going to get u squared over u squared minus 1 du. You're going to get 2u squared divided by u squared minus 1 du. Okay, now remember the other time I said that anytime you are dealing with integration and you come across constant, don't bother yourself working on the constant. Just bring that constant at the back of the integral sign. So when you are done with everything, you just multiply the constant with whatever answer that you had after integrating. Okay, because if you choose to maintain this one here, might be confusing us, making things a little bit what? Tedious. Okay, to avoid that, let's bring this constant outside this integral symbol. So you're going to write these two outside here. Okay, Okay, now after bringing the 2 outside, this is what is left. U squared divided by U squared minus 1 du. Good. What do you think we are going to do here? U squared over U squared minus 1. Another substitution or what? Any idea? Okay, here what we are going to do here is that um, we are going to find a means to write this one to look like what? This denominator. We are going to find a means to write this u squared, which will look like u squared minus 1 at the end of the day. Okay, and remember, after rewriting this, when we compute it, it should give us this one back. If it doesn't, it means we are wrong. We are wrong. We are wrong. So we are going to find the means to rewrite this one in order to get u squared minus 1. Okay, so how are we going to do that? Here you could see that we are having u squared and then minus 1. So to make this one look like this, we are going to first subtract 1 from this and add 1 to it again. Please don't get confused. I said to make this one look like this, we are going to subtract. Here is subtracting. Provided this place is, then we could have just first add 1 to it and then take 1 from it again. But because it's subtracting, we are going to first subtract 1 from this one and then add 1 back to it again. Now, when we do that, you are going to get u squared minus 1 plus 1. And you could see that when you compute it, you're just going to get what? U squared. Okay, so subtract and add 1 to the numerator. So what is the numerator? This is what? The numerator. It is the numerator. So we are going to subtract 1 from it and then we add 1 to it again. As I was saying, now when we subtract 1 from this, you could see that this one look just like this one. Okay, and then we have to add the 1 back in order to eliminate this one, so that after computation the numerator will just give us our u squared back. If you don't add that 1 to it, it will not eliminate the 1 we introduced to help us what? Go further. Okay, so we have to add the 1 back, which will take away this one at the end of the day, and to be left with this one after computation. Okay, so this one is just to help us move to the next step. Okay, good. Okay, so here, that this is not the only approach that you can use. You can also opt for the long division approach, whereby you have to use this one to divide this. It's like an improper fraction, so you have to use this one to reduce this, and then later whatever you had, you just write them, and whatever remains, you write that one as a fraction, then you integrate. By here, I'm choosing to subtract 1 from this. I want guys to come out with ways of solving integral problem. There are sometimes you have to think, in order to find your way through. So we shouldn't stick to only one approach of solving questions. The long division one is there. If you can use that one, and if you use that one, you are not wrong. You get the same answer as this one is going to give you. So have to I want you guys to know that sometimes you can also try and think and come out with some ways which will be similar, or which will be the same thing as something that we know as usual. This one, at the end of the day, when we break it down, you can see that you're going to get the same answer as we will get when we use the long division approach to solve this one. Okay, so when we use the long division, is just we are going to bring this one outside and write this one inside the square root sign. So when we use u squared, u squared divided by u squared will give us what? 1. Then we write that one on top of the square root sign. Now that one multiplied by u squared minus 1 will give us u squared minus 1. Then we subtract. Okay, so when we subtract, what are you going to get? U squared minus u squared will give us 0. And minus 1 minus 1 will give us what? Positive 1. So you are going to get positive 1 at the end of the day. And we are done. We cannot go any further because 1 is what? Less than what? This one. Okay. So what are you going to do? When we divide, what did we get? That is, we had what? 1. So the answer to this one after using the long division is going to give us 1 plus 1 over u squared minus 1. Remember I said when you use the long division approach, whatever that remains or whatever remainder that you get is going to be divided by what? This one. So the long division approach will give us 1 plus 1 over u squared minus 1. And let's see if this one will also give us the same thing as that. Okay, you can see that even this one is more easier than that long division method. Okay, now let's go. That is to me, but it may not be to you. To some people the long division approach is maybe much easier than this one, but any of them that you use, you are correct. Okay, so let's continue. Now u squared minus 1 plus 1. Okay, good. Okay, good. Here u squared minus 1 plus 1. Okay, so what we are going to do is that we are going to split this one into what? Fraction. You're going to split it into fraction, but I'm just going to take two fractions. Now, since we wanted this one to look like this one, we're just going to combine this and this, okay? And we'll leave this one. Okay, so it's going to be u squared minus 1 and then plus what? 1. So when we split it, we are going to get u squared minus 1 over u squared minus 1 plus 1 over u squared minus 1. Okay, I repeat, I said we are going to get u squared minus 1. I said because we want this one to look like this, we are going to get u squared minus 1 divided by u squared minus 1 plus 1 over u squared minus 1. Now, do you know why we did it this way? So that we can cancel out something and then make the work easier. That is why I choose to do it this way. Somebody can also write this one over this, and then this over that, and then also this over that. That's going to be a long process, but I'll not do that. If you do it that way, and at the end of your calculations, maybe you have to do some algebra, in order to get your final answer as this one is going to give us. Okay, so now you can see that this and this are the same. This and this and this are the same. So this will cancel out with this one. It will be left with what? 1. And the answer to this one is going to give us 1 plus 1 over u squared minus 1. Isn't that the same thing as what we had after when we used long division to solve this one? It's the same thing. Okay, it's the same thing. You can, if this one is difficult for you, when you reach here, you can choose to use the long division approach. Okay, or if you think here is more clear, or if you have any question here, you leave that one in the comment section below, and I'll find time to, or no, I'll take my time to, explain certain things to you. Okay. All right. So here, this one and this one are the same. So we'll just cancel out and to give us what? 1. And now here, we just leave it as it is. Okay. So 2 integral 1 plus 1 over u squared minus 1. You see, we've gotten the same answer as we had when we used the long division to divide this one. So all the approaches are the same. No matter what you do, you're going to get the same answer. But if you split this one into 3 fractions, that is that is this one over this over this over this. When you do that, at the end of the day, you're just going to get this one being repeated. So you be encountering difficulty in solving that problem, and you'll be multiplying the difficultiness. Okay, so to avoid that, we just combine this one, because when you combine it, you can eliminate this one when you split it into what? Like fraction. Mind you, here it's a like fraction. It's a like fraction because it's all of them are having what? One, the same denominator. This one is u squared minus 1. Here too is also u squared what? Minus 1. Okay, so when we compute this, remember I said anytime you will write something in another form, it's just the same thing, but we have to write in such a way that it can help you solve whatever problem you are dealing with. But make sure anyhow you will write it, you can easily reverse it. When you compute it, it should give you the same thing as the original was. Now, if you want to get this one back, it's a matter of just writing one denominator, which is here, and then we just add the numerators, which is the same thing as what? This one. And when you compute this one, minus 1 plus 1 is going to give us what? 0, and that is going to give us what? Our x squared here. You see, we haven't changed anything. You see, it's just a matter of critically thinking to come out with ways of what? Solving problems. Okay, good. Sometimes you guys, you can also think and you find another way of solving the problem, not a very unique way, but just simple approaches. But I want you to keep on practicing. If you keep on practicing, the more you practice, the more you gain more knowledge about it. And as you are getting more understanding, you are getting more knowledge about it, the critical thinking itself will come and say, okay, this one, okay, what if I make it this way? What if I make it this way? What if I make this way? If you make it this way and it doesn't work, next time if you try this approach, it will work. And when it works, you have to learn. That's how we learn, guys. So don't stick to one approach. Sometimes try new things, new thing. It is the same thing, but think of, okay, if I want something like if I'm having something like 2, what way can I write 2, which at the end of the day will give me the same thing as what? The 2. And we've learned a lot about if learned about logarithm, you learn that sometimes using natural log you can rewrite this, but at the end of the day to give you back. So if you want to rewrite 2, which at the end of the day will give you back your 2 in order to solve your problem, okay, I can apply natural log. With natural log, you see the base is e. So if I introduce e and bring back the natural log, that e and the base of the natural log will cancel out, and they still give me my 2 back. So I'll just apply that one, and when I do it at the end of the day, it's just going to give me the same 2. So 2 can also be written as e raised to the power natural log of what? 2, which is the same 2 at the end of the day when computed. Okay. All right, that was just a way to encourage you guys to continue learning the math and never give up. And one day I know um, you might become one of these great mathematicians in the world. Only if you give it what? Constant practice, constant practice. So you continue on. Don't fear maths. Don't let it be something that scares you. Try. If you solve it and you get it wrong, nobody will beat you or nobody will hurt you. But I'll just have to, continue solving. If you get it wrong, it doesn't matter. You just keep on. Where necessary, you just seek help. Okay. So that was just by the way, guys. Let's continue. So 1 plus 1 over u squared minus 1 du. Now this one we can split it into two different fractions, into two different integrals. Sorry, that is 2 integral 1 du plus 2 integral 1 over u squared minus 1. This 2 is multiplying the whole of this. Remember, it came out of what? This. So when it's outside here, it's multiplying the whole of this. So if you want to split it, you multiply it across as you are splitting. Okay. Good. Now after splitting, this is what you have gotten. That is integral 1 du and also 1 over u squared minus 1. Okay, now mind you, when we integrate here, I'm just going to split them. We're going to integrate this one alone and also integrate this one alone. So we will first work on this, then later come and work on this one. Then we put our two answers together. So you can either choose to call this one A or B. In your workings, if you can't solve both of them simultaneously, you can split them and give them different names. Let's say this one is A and let's say this one is B, provided you show in your working that let this one be A, let this one be B. So at the end of the day, when you get answer for A and you get answer for B and you just put them together, you'll not be penalized, you'll be marked. That is a way of helping you to solve the problem. Okay, so first let's solve this one and see what we are going to get. Say, like I said, giving it a name, so I'll call this one A and I'll call this one B. So we are starting with what? A. Now when you 2 integral 1d, when you integrate this one, we are going to get what? U. Somebody may say, you said that anytime we come across constant, we shouldn't bother working on it, we should bring it at the back of the integral sign. Yes, this one is 1. So when we bring this one at the back here and it will multiply the 2, we are going to get the 2. But still, the coefficient of this du is still 1. Okay, some people or some teachers will tell you to bring this one outside here, and here he will write the question as well. He will write it as integral du, and then later come and write the answer as u or 2u. We find it difficult knowing why is it u or 2u. So when it's 1 and it's like this, don't bother bringing the constant. When it's like this, it means that you are just going to you're just going to integrate a simple thing. So there's no need. Is there any other variable, any complex state here? No, it's just 1. If you bring it at the back here, still the inside there is still 1. So there's no need for you to bring that one out. Okay. So this one, since is the only thing here that we are going to work on, even if we bring it outside here or not, it's still inside there is still 1 because of the coefficient of maybe this one. Okay, remember 1d is equal to d. Okay, so when you integrate 1, we are going to get u. When you integrate 1, we are going to get what? U. Good. Now when you get 1, you just multiply it by this one. So that will give us 2u. So we are done with A. But if you are wondering, anytime we are integrating 1 or we integrate 1, we just get u or we get x with particular variable that is being differentiated to. Anytime we do that, we are getting either u, y, x, or blah 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 blah. Why? Now if you want to find out why, you don't worry. If you want to know why, you don't worry. I've already done another video which give a proof of why when we integrate 1 we get what? U, or we get what? X. Okay, so I will leave a link to that video for you guys in the description section below, so that if you want to find out why is it that when we integrate one we get what a particular what variable that was being what integrated with respect to. Okay, so I'll leave that one in the link below, and if you want to find out or if you want to know why, you just go and then you enjoy yourself with it. Now let's continue. So the answer to this integral is what? 2u. Now let's move on to this one, integrating b. Now let's repeat b. Let's write b. One over u squared minus 1. Now here, like I said, if you bring this one outside here, the numerator will still be hot 1. Okay, so just don't bother bringing it out. I'll say even it's, let's say, not just more than 1, but when you see that the one is maybe alone like this one, you just leave as it is, and if it is also like this, you just leave as it is. But when it's either when it's more than 1, you just bring it out, or maybe, well, 1, if there are a lot of variables involved and we had 1 among the integrals, that among the work what we are working on, you just multiply it through. When you multiply it through, it get vanished, so just no need for you to bring it out. So, well, we say when it's more than 1, you just say let me bring it outside the integral sign. Okay, here, because this one is 1, the numerator is 1, we are going to factorize here. I know some of you might add that question. So why is it that there, when where we were having u squared over um u squared minus 1, why didn't we factorize it? Of course, like I said, if your math is good, somebody can factorize it from that point and then be able to get his final answer, as we are going to get for this one. But if your math is not good, I'll urge you to just follow what we are going to do, and when you get something of that nature, just follow what this same what approach. Now that we don't have any variable here and the numerator is just 1, we are going to what factorize this. So I'm not saying anytime you get u squared or x squared over blah blah, you shouldn't factorize. You can choose to. If I said only if you are good in math and you can deal with some, you know how to punch or deal with some other little bit complex calculations that you come across, like I said. Okay, so with me, I want everything to be simple for you guys. Okay, so let's continue. Here we are going to factorize. Now when you factorize this one, when you factorize x squared u squared minus 1, this is what you are going to get. Now u squared minus 1, 1 can also be written as what? 1 squared, which is the same as what? 1. You see, that is why I said when you get 1, don't bother bringing it outside the integral sign. Okay, so u squared minus 1, when you want to factorize it, you treat it as a difference of 2 squares, and we all know the answer to difference of 2 squares, that is a squared minus b squared is equal to a plus b, a minus b. So you just apply the same thing here. So you're going to get u plus 1 and then u minus 1. Okay, here to solve this one, we are going to use partial fractions. And you're going to use partial fractions. Okay, so to use partial fractions to solve this one, we first have to split it. That is why I've written this one here. Split it into partial fractions. And to do that, we first have to split it. And to split it, we'll just take let's say any variable at all. Generally we normally use a, b, and c, but because I've already used a in part of the workings, here I'm not going to use a. I'm not going to use a. I said nobody will penalize you, so I'm not going to use a. If I do that, it will confuse us in terms of writing our answers. So I'm going to use maybe C and D, which is different from the A and B. Generally, we use A, B, C, like in that order. Generally, we use A and B, but which variable that we use depends on the nature of the denominator. We have linear factor, quadratic factor, and repeated factor. With quadratic factor, you will use AS squared plus B, and then let's say C. With repeated factor, you might use A, B, BS squared plus, let's say C. Something like that. With linear factor, we only use two variables. That is A, B, or C, D, or blah, blah. So here I'm going to use C and D. So you just take, you always write them as numerators. So if I use C for the first one, it's going to be C over U plus 1 plus D over U minus 1. Good. C over C plus U plus 1 and then D over U minus what? 1. Alright. Now how are we going to use the partial fraction to solve this one? Yeah. Well, to find, first we have to know the value for C, also know the value for what? D. Okay. And to do that, we have to use the cover up rule method. We have to use the cover up rule method. There are two rules or two approach of finding the value of what? C and D, or find the variables in what? Partial fractions. That is expanded method and then the cover up rule method. The cover up rule means you are to cover one and then you work on the other. Covering one means you are eliminating it and then you work on the other. And then the expanded form means you are to expand the whole thing, factorize, and then you do comparison to get your answer. Okay, so this is how the cover up rule is going to work. This one will be multiplied by this, like cross multiplication. So you just multiply this by this one and also this by this, and then you divide it by the product of the denominator, which is this and this. When you multiply, it's just the same thing as what? This and that. Okay, and then you equate it to what? This one here, this one here. You don't worry, I'll do another video which will go into details of the partial fractions for you guys. Okay, so you equate it to what? This one here. So at the end of the day, you are going to get 1 is equal to C into bracket U minus 1 plus D into bracket C U plus 1, and it's all because now the idea of equating this and this to 1 is because we will equate the whole of this one to this, the whole of this 1 over U plus 1 and then U minus 1 to C into bracket U minus 1 plus D into bracket U plus 1 divided by U plus 1 multiplied by U minus 1. And because both left and right hand side are having the same denominator, you just multiply that one through. And when you do that, you see that that one will eliminate this one and also eliminate this one, and to be left with 1 is equal to C U minus 1 plus D U plus 1. Okay, so using the cover up rule, we are going to put U is equal to either 1 or U is equal to minus 1 into any of these, and then so first let's put U is equal to minus 1. Okay, put U is equal to minus 1. Wherever you find U down there or over there, we just put minus 1 there. So let's put U is equal to minus 1. So 1 is equal to minus 1. When you put U is equal to minus 1, this one here is 1 minus 1, and here is 1 plus 1. With cover up, I said, when you use your hands to, you place your hands on the other, you can see that you are only seeing 1. And that is, everybody will think it has been eliminated. If you don't see the other one, you say it's not there. It has been eliminated. So how do you eliminate it? if you put u equal to minus 1, this and this will be 0. 0 multiplied by this will be d. So it's gone. This and this will give us what? Minus 2. So you're going to get 1 is equal to minus 2c. If you divide, let's divide both sides by minus 2, and that's going to give us c is equal to minus half. If you divide both sides by minus 2, this take away this, and to be left with this. So c is equal to minus half. Now, putting u is equal to minus 1 eliminated what? D. Now let's put u is equal to positive 1 into the original equation. Now when we do that, okay, here 1 minus 1 will give us what? 0. And 0 multiplied by 2 will give us what? 0. Now d, here and here will give us what? 2d. So 1 is equal to 2d. Divide both sides by 2. And you're going to get d is equal to half. Now that we know the value for c and d, let's put them into the integral. Yeah, put c is equal to minus half, and then d is equal to half into the integral. Okay, so let's put them. Okay, good. Here is supposed to be 1, the whole of this 1 over this, but when you do that, the 2 will actually come down and multiply this. So I just do that one straightforward for you guys, because you know division, when you are divided fractions, I mean, if you are a divided fraction, you know what happens. So there's no need for me to maintain that one. So I just do that one straight away. Okay, so when you come here, the value for d is what? Half. And when you do that, the same thing, the 2 come down eventually. So 1 over minus half into bracket this, and also 1 over 2 into bracket what? That. Well, we are having half here and also having half here. What are you going to do? Why don't we factor that one out? Let's factor that one out and see what will happen. But when we bring the half outside, well, we will just rewrite in a way which is more what? Let's say more attractive, or write it in a way that looks good for us. Minus this one plus this, very something else. So why don't we make it something like this one minus this? That one looks good, right? That one looks nice. So let's do that. You see, this one looks nice as compared to the other one. Yeah. So here, like I said, you are just going to factor out the 1 over 2. It's going to factor out 1 over 2. Remember I said, though we are taking the half outside, but still there'll still be 1 here, because here it's just like trillions of 1 times trillions of 1 will just give you 1. So when you take 1, it's still there left with about billions of 1 by billions of 1. So just can take many ones as you want outside, and there will still be somewhat left. Okay, so when you're going to half is here and also half is here. So when we factor it out, and then we multiply it by this. Okay, good. So here this and this will cancel out, and here we are going to get 1 over u minus 1 minus 1 over u plus 1 du. Okay, now here we all know what we get when we are integrating something of this nature. Normally we are familiar with something like when the variable is single. I mean, when it's not being separated by anything, when it's not being squared, like 1 over u, or 1 over x, 1 over y. That one, we are more familiar with that one than this. The idea here is that when it's u minus 1 and you are to integrate, because when you differentiate this one, it just gives you the same thing as either du, and let's say if I let that one be equal to p, dp or dx and then du, it normally give us the same answer as what? When the integral to 1 over what? Let's say x. How you integrate 1 over x is the same thing as how you are going to integrate this one. Okay, so the answer to this one is going to give us what? Natural log absolute value of u minus 1. Absolute value of what? U minus 1. And we get that, we had that because though we know that 1 over u is equal to ln absolute value of u, we can make that one single by making another substitution here. You say p is equal to u minus 1. Now let's differentiate. dp will be equal to du. You see? So when you bring that one into the integral sign, you're going to get 1 over p dp. You see? And 1 over p dp, we know that one. That is going to give us natural log absolute value of what? P. And what is p? P is just u minus 1. So that is why when you integrate this, something of this nature, you always get this one what? Back. It's because of what? Substitution that we do. But just that, because most students know the answer to something of this nature, some teachers just don't just bother themselves showing how the answer to this one is what gotten. Okay, good. So when you integrate this, you're going to get natural log, that is ln absolute value of u minus 1. The same thing is applied here. Ln absolute value of what? U plus 1. Okay, now here this and this has been cancelled. It has left with what? 1. Okay, all right, so let's write our answer. Now from the laws of logarithm, you know, log a minus log b can also be written as what? Log a over b. That is from the law of what? Quotient. From the law of quotient. So we will just apply that one here. Okay, so let's continue. Good. Now that we've gotten our answers, that is the answer to the integral question we are working on, that is which is ln absolute value of u minus 1 minus ln absolute value of u plus 1. Remember we had two answers, we split them into two. So now that we know the answer to each of them, remember I said earlier on that after splitting and you are done with what? Integrating, just put them back. Add a and b. Mind you, adding a and b does not mean you are to rewrite the question for a and b. Integrating a means finding the answer for what? A. I just call that one A to help us identify the answer for that question. So if you integrate that, let's say integral 1 du and we had 2u, I'll call that one A because that is answer we had after integrating that one. So instead of writing that one directly, I just do this one to recall you what we did before getting our answers. Okay, so we are just going to add a and b. So a and b does not mean the integral, but the answers that we had to what? A and b. Okay, so let's write them. A was what? 2u and b is what? Natural log of absolute value u minus 1 minus natural log u plus 1. Remember the absolute value is the one be taken. Okay, now let's continue. Yeah, remember I said we are going to apply the law of logarithm, that is the law of quotient of logarithm, which says that log a minus log b can be written as log a divided by b, log a divided by b. So when you apply that one here, please don't let this and that confuse you. assume that this one is A and then this one is B. So when you are rewriting, just assume that A is here, so you just write your A there, which is what? Ideally this one, and then this one is what? B. So it's just going to give us ln, don't forget your absolute value, u over 1 divided by u plus 1. Okay, we are done, but we are not done. We entered this word to help us solve our problem. Okay, so when we are done, so if you are done, you could see that even this question even telling us that this one we are not done, because when you look in with equation, everything either on the left hand side or right hand side has to be the same, not equivalent. Equal is different from equivalent. 250 pesos is equivalent to 1 CD paper, because here we are having two different items. Here is paper and here is metal coins, but 1 CD paper is equal to 1 CD paper. Everything is just the same. But when you come here, are they the same? Here we are having u's and here we are having x. They are not the same. So what do you have to do? You have to go back to what? The x word. But we also, going back to the x word, we know that u is equal to square root of x. U is equal to square root of what? X. So since we know that u is equal to square root of x, wherever we see u, we are going to put square root of what? X there. Somebody may choose to replace the u with square root of x the moment he had these answers, and then later on simplify them to this state. You are not wrong. Any of them that you do, you are correct. Okay, so let's proceed. So now let's replace the u with what? Square root of x, and let's see what will happen. Okay, so after replacing the u with square root of x, we're having 2 square root of x plus ln absolute value square root of x minus 1 divided by square root of x plus 1. So this is the answer to this integral, but not is the answer, but not yet the answer, because we are not done. I've told you guys several times that after integrating, no matter how difficult the question was and how best you try, or how hard or how manageable you try to get your answer, if the answer is even 1000% correct, and if you don't bring your plus c, you will lose some marks. And I've said it earlier that you don't know how the marking scheme is going to award the marks. Some marking scheme will not give you anything here, but rather whatever that was supposed to be awarded here will be rather awarded in addition to the final answer, which is what? When you add the c back. Okay, so let's add our plus c, just don't forget that. So concluding, therefore, this integral is equal to this one plus c. Plus c. Good. Here I wrote plus k, and I guess you know that I know that, and I'm sure that nobody's going to ask why is it that I said plus c, but here I've written k. I hope nobody's going to ask me question, because I have explained that one earlier on, that I should have used a and b, but because I've already used it in part of the workings, I chose c and d for the partial fraction part. Here also, because I have used the c and d, or I've used c already in the workings, I can't bring that c here. Somebody may refer to that. Okay, so I will choose another variable to represent the constant. In math, the constant that we normally represent, that is c, k, e, blah blah blah. By here, when you bring e here, well it depends. So because it's an integral question, when you bring e there, it's a final answer to an integral question. When you bring e there, I don't think you'll be penalized, because the marker will assume that that is your hot constant. But generally, I said we normally use what? C. But just that because I've already used C, I decided to bring what? K there. Okay. So The answer to this integral is 2 square root of x plus L and absolute value square root of x minus 1 divided by square root of x plus 1 plus what? K. This means we are done. Okay. All right. So that is how the substitution approach is being used to solve problems of what? This nature. Okay. Those of you who want me, those of you who wish to differentiate this, should draw my attention in the comment section below, and I'll do so for them. If you want the differentiation for this one to confirm this answer, or if you want to find out that this answer is maybe correct or blah blah blah, just let me know. If you want know how this one can be differentiated to get this, or if you want us to differentiate this one, okay, you let me know in the comment section and I will do that for you. But before that, I'll urge all of you to try and differentiate this to find out if you can get this. If we're able to differentiate and get this, means it means this it makes this answer hot, correct? It makes this answer hot, correct? But I'll still urge all of you to try and then differentiate to find out if the answer we had to this integral is what, correct, or differentiate to find out if you can get what this. Ideally, when you differentiate this, you're going to get this at the end of the day. As I said earlier on, I've said already and I'm saying it again. Differentiation and integration is like they move together. It was like this and they integrated, they differentiated it to get this, and now they've taken this one away and they said we should integrate this one to what, find how the differentiation question was like. And so at the end of the day, this is how it was like before it was being what, differentiated. Okay. All right. Okay guys, that's it for you. Please, if any of you has any question concerning what we've just did, please kindly leave it in the comment section below and I will quickly respond to it for you. Make sure you don't hesitate. Feel free to ask any question at all and I'll try my best to answer you. We are all here to what, learn. Okay. All right. um we are done. So that's it guys. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.